All right, I trust you did well on that quiz. Let's get geared up for another shot. Just kidding, just kidding. We're going to stop at 2 quizzes today. I want you to just take out your notes. You don't need your books out just yet, but I want you to think about something. Suppose I told you that the sine of theta is a half. And I asked you, what is theta? Well, we could, of course, take the arc sine of both sides. We could pull out our calculators. But supposing we weren't permitted to use our calculators, like you won't be allowed to do on a problem like this, how would you figure it out? No, you're trying to find theta. So again, on the calculator, you take the arc sine of both sides. But if I'm not going to let you do that, there's got to be another way to figure it out.
So what will be like?
We know sine is what over what? Okay. Do we have a special triangle that has a side, a leg of 1 and a hypotenuse of 2?
Yes.
Which one?
30.
We know the 30, 60, 90 has those lines in it, correct? Now that means it's either 60 or it's 30. The question is, which one? Well, remember, the opposite has to be 1. For which angle is the opposite 1 while the hypotenuse is 2?
30 degrees.
So apparently, theta is a 30-degree angle. How about this? Write this one down. Suppose we knew that the cosine of alpha is square root of 2 over 2. We know cosine's what over what, class? Adjacent over hypotenuse. Do we have a special triangle for which a leg is square root of 2 and the hypotenuse is 2? No. But wait a second. This is merely a rationalized form of another fraction. What fraction has been rationalized here? 1 over the square root of 2. Okay, do we have a special triangle for which there's a leg of 1 and a hypotenuse of square root of 2?
Yes.
Which one?
45.
Yeah, the 45, 45, 90 has legs of 1 and a square root of 2. Well, that kind of narrows it down. Doesn't matter which angle you pick, class. The angle must be 45 degrees. Do you see the thought process here? All right, how about this one? Suppose we know that the tangent of gamma is square root of 3 over 3. Thoughts on how I would find gamma?
Square root of 3 is at 36 and 90.
Okay, so tangent's what over what, though?
Opposite over adjacent.
Opposite over adjacent. Do we have legs of square root of 3 and 3 in a triangle?
Not 3.
Not 3.
But we can do the same thing with the last
Oh, yeah. This is merely a rationalized form of another fraction.
1 over square root of 3.
So you see how unrationalizing? Okay, do we have legs of 1 and square root of 3?
Yes.
Yeah. Now, for which angle is the opposite 1 and the adjacent square root of 3?
30 degrees.
30 degrees, opposite, adjacent. So apparently, gamma is 30 degrees. Make sense? So I get the feel for this?
Yeah.
All right, suppose we knew that the cotangent of phi is 1?
1 over 1.
Ah, yeah, we got to make it a fraction, 1 over 1. Of course, we know cotangent's what over what?
Adjacent over opposite.
Adjacent over opposite. Do we have a triangle where both legs are 1?
Yes.
Yeah, which one?
0.
45, 45, 90,
Yeah.
both
I'll
legs
think of 0.
are 1. Now, the 0, 90, 90 does have a couple of 1s in it, but one of them's the hypotenuse, right?
Yep.
For both legs to be 1, we must be dealing with the 45, 45, 90, which means that phi is
45 degrees.
45 degrees. Suppose I told you that the secant of beta is undefined. Well, that narrows down which triangle we're considering, right? What triangle?
90, 90, 0.
The 0, 90, 90 triangle. But the question is, which angle, the 0 or the 90? Are we looking at? Well, remember, to have undefined means the ratio must be 1 over 0. Something over 0. We're going to go with 1 over 0. And secant's what over what?
Hypotenuse over adjacent.
Hypotenuse over adjacent. So obviously for both of these the hypotenuse is 1. But for which angle is the adjacent leg 0?
90 degrees.
The 90 degrees has an adjacent leg of 0, so apparently beta is 90 degrees. What if I told you that the cosecant of sigma is 2 times the square root of 3 over 3? Well,
You had to rationalize it.
unrationalize it, huh?
So 2 over square root.
All right, and cosecant's what over what?
Hypotenuse over opposite.
Hypotenuse over opposite. Okay, so for which angle is there a hypotenuse of 2 and an opposite leg of square root of 3?
39.
That's the right triangle here, right? But which angle has an opposite
60.
square root of 3?
Yeah, 60.
The 60. So apparently sigma is 60 degrees. Do you see how to find angles that are based off of special triangles? Turn your textbooks, if you would, to page 40. And I want you to do numbers 51 to 59. Page 40, do numbers 51 to 59. Let me go ahead and leave these triangles on the chalkboard for you. Or you could draw them on your own paper. Page 40. Numbers 51 to 59. finished. Jamie's finished. And Ethan's finished. Let's see how we did on these. Number 51. What did you get for your answer, Ethan?
60 degrees.
60 degrees. Or, since it said find each angle in radians, we could write our answer as
Pi over 3.
pi over 3. Number 52, Jamie.
30 degrees.
Which in radians would be?
Pi over 6.
Number 53, Quentin.
Pi over 4.
Initially 45 degrees, which is pi over 4. Good. Number 54, Ethan.
Pi over 3.
Pi over 3, 60 degrees. Number 55, Jamie.
0 degrees.
Which is
0.
0 radians. Number 56.
Pi over 3.
Pi over 3 starts out as 60 degrees there. Number 57, Ethan.
0.
Ooh, let's see. Cosecant is 1 over what?
Hypotenuse over opposite.
Hypotenuse over, there isn't an opposite, but if we make it another 1, we want an angle that has a hypotenuse of 1 and an opposite leg of 1. Well, leg and hypotenuse can't be equal except in this triangle. We want the hypotenuse to be 1 and the opposite leg to be 1. What's opposite the 1? 90 degrees. So we'll change that to pi over 2. And then number 58, Jamie.
45 degrees.
Which is
pi over 4.
pi over 4. And then 59, Quentin. Pi over 6, that 30 degree angle. Questions on those? Number 60 says, how many radians does each hand on a clock pass through in 12 hours? Let's start with the hour hand. How many times does the hour hand go around in 12 hours?
12
times.
Once.
Oh.
In 12 hours, the hour hand will only completely go around once. So for the hour hand, how many radians is that hand? One revolution. How many radians?
12.
2 pi. 2 pi is a revolutionary idea. Okay. What about the minute hand? How many times does the minute hand go around?
12.
Right, it goes around 1 time every hour, so in 12 hours it goes around 12 times. Every time around is? 2 pi, so if it goes around 12 times, 24 pi. And then the second hand. This is going to be fun. How many times does the second hand go around every minute?
1 time.
Once. So every hour it'll go around 60 times. So in 12 hours it'll go around
3,600.
60 times an hour it goes around. 12 hours would make
Half of that, so 3,000.
720 times.
720.
Right, 720 times it goes around in 12 hours. Each time around is 2 pi. So 720 trips around, every one of those is 2 pi. 1,440 pi radians each half day. That's random pi. Number 61. A 22-inch diameter pizza was cut into 16 congruent pieces. Find the number of radians of pizza eaten by a pizza lover who ate 5 pieces. By the way, does the diameter even matter here? No, but 22 inches is a really big pizza. It's pretty awesome. Okay, let's see. The whole pizza is cut into 16 pieces, right? All right, now the whole pizza is how many radians? 2 pi. And it's chopped into 16 pieces. So if we divide it into 16 pieces, that gives us how big each piece is. Stay with me, right? But he doesn't eat 1 piece. The pizza lover eats 5 pieces. 10 pi over 16, which would reduce to
5 pi over 8.
5 pi over 8. 5 pi over 8 radians of pizza. All right, questions on those? No homework over the 3-day weekend, at least not for me in this class. Physics may be a bit different story. But no homework for me in this class. And you are dismissed. Have a wonderful rest of your day.